Hi everyone, I miss you guys. Hope you're doing well. Coming to you for what would be like our week 4 lesson. After kind of reading back from your responses, it sounds like you guys could use some extra practice on this U-Substitution, which makes sense. We normally would have spent a lot more time on it in class. What I'm going to do is just go through 4 examples of different types we've done already, including trig. I know some of you wanted extra practice with that. And then I'll give you some more problems to work on this week. Okay? Again, I miss you guys. I hope you're all doing well. This is could be for Mrs. Fitch and Mr. Zivzak's classes. He will possibly be using this as well. Anyways, I did just kind of want to touch base with those of you in my calc. I know that I've talked to one of the classes, I'm not sure which period it was, about my lemon plant at home. That remember the story how I had grown a lemon tree, or Mr. Fitch is growing a lemon tree from my lemon, from my iced tea that started growing in my drain in my bathroom sink. So here is my lemon plant from a tiny little seed, and now it's growing like this. In 5 or 6 years, come see me, I'll give you a lemon from it, right? That's Mr. Fitch's dream. And then here's the apple trees that he's growing from apple seeds out of an apple. So we try and grow everything here at the Fitch house. All right, anyways, setting up my makeshift math work. All right, anyways, again, 4 examples just to kind of go through. Extra practice, nothing really new today with U-Substitution. But if we're looking at this first one here, I don't want you guys to forget how to do integration the easiest way. And the easiest way, if we can, is to get rid of division if at all possible. And so in this problem, I could easily just go ahead and divide everything by x, rewriting the original integrand, which would just give me 4x squared minus 3x plus 8. Now I don't have any more division in this problem. There's no need for any type of U-substitution like that. I just need to simply integrate each of my 3 terms. Remember, integrating is adding 1 to the exponent, dividing by the new exponent. When I integrate here, my new exponent will be x cubed, and I will be dividing that. And so I will have 4/3 x cubed minus, now my new exponent, if I add 1 here, will be 2. Divide by 2 and have a 3. Hold on 1 second. Here's Parker. What's up, buddy? I'm on. Okay, perfect. I'll be out in a couple minutes, okay? All right. Parker says hi, everyone. Say hi, Parker.
Hi.
All right, back to it. Anyways, for this 3rd term, we're going to add 1 to the exponent. Well, that's just now going to be x to the 1st. And we don't need to divide by 1. And then remember, this is an indefinite integral. We are not defining our bounds. Therefore, we need to make sure we remember to add r plus c to the end. That is the basic integral problem. There is no need to do U-substitution. Always think about that with problems. Maybe you can reduce them before you integrate. All right, question 2. Checking this one out for a second here. This one, 2 different options. I noticed that I have an exponent. Well, hey, maybe I could square that out. That wouldn't take that long. And then I could go ahead and multiply in. And then I could avoid U-substitution completely. However, if I don't want to go through all of that multiplication, that seems like a lot of work, well, then maybe I'm going to try U-substitution. So in this problem, I'm looking at the inner term here appears to be 3x cubed plus 3. I'm going to let u equal that inner part. That would now give me, well, I'm going to bring this whole thing to the front, u squared, and then I would still have 18x squared dx behind it. Now my goal is to remember to get everything in terms of u, so I'm going to work to get rid of 18x squared dx. The way that I'm going to do that is by taking the derivative of my u value. The derivative here would be 9x squared, and then I was having du over dx, but I'm going to move the dx here, which would now give me 9x squared dx. Well, crap. This is not matching up exactly, but at least this part is. So what I could do is I still have the 18. I could just leave that there, and I could get rid of x squared dx and write that as 1/9 du. Now I've rewritten my integral all in terms of u. I can clean this up. I can say that this is really a 2. and the 2 is going to go out in front of the integral, and I'm left with u squared du. Now I've got a basic integrand, and I can go ahead and integrate and say 2/3 u cubed. Okay, I'm going to plug back in what my u value was, which was 3x cubed plus 3. And then normally I would put plus c if this was just an indefinite integral, but we have a defined value, so now I need to actually evaluate this. If I remember plugging in my upper value and subtracting from that my lower value. All right, so then once I go ahead and I clean this up, this is going to be 3 squared, which is 9, minus, I'm just double checking my work, this would be -1, you can't even see my work down here, sorry guys. This would be -1 cubed is -1, times 3 is -3, -3 plus 3 is 0 for this whole part, 0 squared is just 0. So we would get to here. And then I could go ahead and say, well, 2/3 of 9 is 6. And I have my answer. Okay? So that would be a basic U substitution. Wasn't too bad. The only issue we had was that our values weren't initially matching up exactly. No problem. We were able to still evaluate. All right, let's throw a trig one in here. I tried to find a more difficult problem. There's a lot of difficult problems, obviously, but this one, why does this look so fuzzy? Let's see if that works at all. All right, trying here. This looks like a messy trig problem. I've got the cosine of x, but I don't have the sine of x. I have the sine of the sine of x. So to me, this appears to be an inner function. That's what I'm going to let u equal. I'm going to let u equal this inner part, which is the sine of x. So cleaning this up, and notice this is a definite integral, so we'll have to evaluate this at the end as well. I right now have, whoops, I'm going to erase. Look at my kids' cute pencils. All right, anyways, back at it, sorry. I'm going to move this part with the substitution to the front, so I have the sine of u now times the cosine of x dx. Remember, when we do u substitution, our goal is to get everything in terms of u. So I'm going to need to work to get rid of cosine of x dx. This needs to become a du. So in order for that to be a du, we need to find the derivative over here. The derivative of sine is cosine. And then I'm moving my dx over, and well, that's going to work out nice. I have the du is equal to the cosine of x dx, which is exactly what I have here. Therefore, this whole thing just becomes du. And now I have a very basic integral to integrate. The integral of sine, remember these are one of the ones that you must memorize. The integral of sine is negative cosine. And we're not going to put our plus c because this is a defined value, but I'm also going to go back and resubstitute what u was. U was the sine of x. Now I can go ahead and evaluate that between 0 and pi over 2. When I do that, I'm going to pull the negative out, and then I'm going to do upper minus lower, and I'm going to plug right into the problem. Cosine of the sine of pi over 2 minus cosine of the sine of 0. All right, you'll pull out your unit circle if you don't have one. You can always look one up online. Super easy to find them anywhere. And we're going to evaluate this as best we can. We're going to start with the sine of pi over 2. Well, what is the y value at pi over 2? Well, at pi over 2, the y value is 1. So this whole thing becomes a 1. Minus, what is the y value at the angle of 0? Well, over here, at the angle of 0, the y value is 0. So we have that. Now we can clean it up a little bit more. This says, what is the x value at the angle of 1 radian? That is not one of my common 16 angles. 1, the angle of 1 is not common on my unit circle. Therefore, I'm going to just leave it as that. I'm just going to say that is the cosine of 1 minus, well, this one I can't evaluate. This says, what is the x? Did I say y's over here? If I was saying cosine is y's, I'm sorry. Cosine is x. Maybe I did. I'm not sure. Here I'm trying to evaluate this part. What is the x value at the angle of 0? Well, the angle of 0 is one of my common trig angles. And here at 0, the x value is 1. Therefore, the cosine of 0 is 1. Last but not least, I'm just going to throw this negative back in. And this is going to now become a positive 1 minus the cosine of 1. That is as far as I can go with this problem. I'm just going to leave it that way. I know normally these things clean up neater, but they don't in this case because this is an irrational value that we can't define. All right, last one for the day. Looking here, this would be our hardest type of U-substitution where we have to kind of double substitute. When I look here, I notice that I have multiplication, and I'm going to rewrite this problem as x minus 1 to the 1/2 power times x plus 3. And I've got multiplication that I cannot get rid of due to this exponent. So I'm going to have to think about U-substitution here. And I'm going to let U be the inner function, and to me the inner function is what is being raised to an exponent. So that would make this whole part here become U to the 1/2. But we still have this x plus 3 dx in the back that now I need to try and change. I'm working to get that to be U terms rather than x's. So the way that we're going to get rid of dx is by taking the derivative over here. The derivative of x is just 1, and the derivative of 1 is 0. So therefore, we get this. I'm going to bring over, and I'm going to say that du is equal to 1 dx. Well, the only thing that helps me with is this part here. Okay. So I'm still stuck with an x, and that x needs to be somehow rewritten in terms of u. That's going to have to come from up here now. And I'm going to have to solve for x in terms of u. Well, to solve for x, I'm going to say that x is equal to u plus 1. I can now take that and substitute in down here. Notice I've not done anything with the power rule yet. I'm literally just rewriting my problem. So x is u plus 1, then we still have the plus 3 and the du behind it. That brings me then to u plus 4 times du. Now I still have everything in terms of u, but there's multiplication. Well, no big deal. Now I can distribute. And this would give me u to the 3/2 plus 4u to the 1/2. Now I've gotten rid of multiplication. Let's use our power rule. My new exponent will be 5/2, and instead of dividing by 5/2, I'll multiply by 2/5. Plus, my new exponent here will be u to the 3/2, and instead of dividing by 3/2, I'm going to multiply by 2/3. I'm going to clean that up a little bit. And instead of u, I'm going to plug what u is again, because we're going back to our x's, which is what our problem started with. Here I'm going to say 8/3. And instead of u, I'm going to put what x it is in terms of x again. Whoops. Sorry. Plus c, because this is an indefinite integral going back to the beginning. Don't forget that plus c, everybody. And there we go. This is how we can work to find the area underneath the curve of this messy looking function, where basic power rules did not apply until we did our substitution. Okay, so feel free to watch this as many times as you need. Guys, I really, really miss you. God, I'm not a first grade kindergarten or preschool teacher. I'd rather be teaching calc all day long. Feel free, reach out if you need help on problems. Contact me via email, and then we'll figure out a way to get in touch, whether it's Google Hangouts or Meets or anything like that. But keep practicing this stuff. This is not easy, and it's going to be necessary as we go further along and we need to do rotations and three-dimensional shapes and volume and area of those. So hang in there. We'll get through this. I am definitely thinking of you seniors. This is not the way you want to spend your senior year, but this is something you will be able to talk to your children and grandchildren about someday. So hang in there. Love you all. Take care.